Okay, well first we're going to look at a correlation. Okay, so this is one of the examples from the lecture. So we've got 8 children and we have their height in inches and their weight in pounds. So you don't think we have, really short children in centimeters and very heavy in kilos. So here we have their height and their weight. Okay, so we're going to go to this button that says correlation. So we want to see if there's a relationship. So we assume that there's going to be a positive relationship, right? The taller you are, the more you should weigh. Okay, so we're going to click here, correlation. We're going to click on correlation analysis. Okay, so and we're going to highlight our data, so height and weight. Okay, it's going to ask you the type of correlation. We're using a Pearson correlation. There are a couple other different types of correlation, and they're dependent on what type of variables you have. And I have a little list in the back of the PowerPoint for you that you can use for a little bit more information. Okay, so we're going to have descriptive statistics. That's great. We're going to have correlations. We've told it to bold the significant correlation, so that helps us know. Our p-values and the coefficient of determination. Okay, so if you're watching this before you've gotten through the whole lecture, you don't know what that is. So I'll explain it when I get there. Charts, there's no need for charts here. Okay, so we're just going to click OK. Continue. OK. All right, so here we have our descriptives for height. Okay, mean, mean, minimum, maximum, standard deviation. Same thing with weight, no problem. Okay, then we have our correlation matrix. So you can see that, if you correlate height to itself, you're going to get 1. Not a surprise. Okay, and you also see we have the same value for the correlation of weight with height and height with weight. Okay, notice they're not bold, okay? Because if we look down here at our p-value chart, we'll see the significance is 0.107, 0.11, okay? Even though this looks like it's actually a fairly strong correlation, because we have actually a relatively small sample size, it's going to be harder for us to have things to be significant. And this is true with all statistical tests. The bigger your n, the more likely you are to get things that are significant, okay? And now here at the bottom, we have the coefficient of determination, okay? Okay, this is r squared, okay? We're going to see this term again when we get to regression. Now, the coefficient of determination, if you haven't read forward yet, is actually the amount of variance each variable is explaining in each other. Okay, how much shared variance do they have? And all this is basically, it's this value squared. Okay, so if you square this value, 0.612, you're going to get 0.675. And that's the amount of variance they're explaining in each other. Okay, and that's what you're going to get out of a correlation test. Okay, see you later.